This lesson deals with the measure of position percentile. So when we are calculating percentiles, we're basically calculating a measure of position. So we're determining where a certain number fits into a long list of data. So the percentile will indicate the percentage of values that are below or equal to a given data. For example, if we say that your grade is in the 75th percentile, that would mean that 75% of people's grades are below or equal to yours. So when we're dealing with percentiles, basically what we're doing is we're taking our entire data set, our entire distribution, all the numbers, and we divide it into 100 groups that each contain 1% of the data. So like we've done down here. Here on my list of numbers, we've skipped the middle ones just to condense this a little bit. And we're showing, well, these first three numbers represent 1% of the data. These three represent another 1%, etc. So we would have 100 groups here to indicate all our percentiles. So the rank of each of these subgroups is the percentile of the data value it contains. So for example, the number 3, it is contained in the first percentile. So it's in the first percentile. That means that there is 1% of the data that's below it. The number 30 is in the 98th percentile. So 98% of the values are less than 30 or equal to 30. Another example would be your mark in the class. So suppose on the last test, your mark that you earned was in the 95th percentile of your class. Well, that means that 95% of the marks in the class are below yours or equal to yours. To calculate percentile, we use this formula. So if we're trying to find the percentile rank of a certain number, so of x, we need to find the number of data values that are less than x. Then we need to find the number of data values that are equal to x, and we divide that by 2. Add these up, divide by all the data values we have together, and we multiply by 100. We'll use this formula in a moment in an example. Very important to note though is this you should highlight, put a big star, make sure you remember it. If the number you get for percentile rank is not a whole number, then you have to round it up. Always, always round up. Even if you get, suppose you calculate 2.1. You're going to round that up to the 3rd percentile. And I'll show you why with this example. So 2.1 means it's past the 2nd percentile. It's not in the 2nd percentile. Now it's up here. Once you pass the 2nd percentile, you fall right away into the 3rd percentile. So when you're calculating percentile, you're always, always rounding up. The other calculation you can also do is, well, if you know the percentile, how can you determine what number it is? So if you know you're in the 95th percentile, what is your grade that puts you in the 95th percentile? So that's the reverse calculation. There are 2 steps to this calculation. The first one is you're going to determine what the position is of this data value. So in other words, you need to find how many data values are less than or equal to that value. So to find the position, you take the percentile rank divided by 100 times the total number of data values. That'll tell you in what position that number is. But then the next thing you need to do is you need to determine which data value is in that position. Another important note here on rounding, if it's not a whole number, you're always going to round down. So this can get confusing because when you're calculating percentile, you round up, but when you know the percentile and you're finding the position, you always round down. So let's try applying all this in an example. In our first example, we're going to determine the percentile of 21. So we're given this distribution here. This is the list of all my numbers. We have 158 values here. We didn't list them all. We listed the first few. This here indicates that there are 61 values between 8 and 19. We don't know what those values are, but I'm probably for the problems we're going to do, we don't need to know what they are. Same thing here, in between here and here, there's 41 values, and here there's 36, to give us a total of 158. So we're going to determine the percentile of 21, which is right here. So to find the percentile, we need to start by finding the number of data values that are less than x. So my x is 21. How many values are less than 21? Well, we have 61 values here, plus we also have the 19, the 8, the 7, and the 6. So that's 61 plus 1, 2, 3, 4. So that means we have 65 data values that are less than 21. Plus, now we need to find how many are also equal to 21. How many numbers are 21? How many times does 21 appear? And we'll divide that by 2. So as we can see, we have 21 appearing 3 times. So that's 3 divided by 2. All of this is going to be divided by the total number of datas in the distribution. So we have 158 values in the distribution, so we have to divide by 158 and then times 100. So please pause the video here. Let's just make sure you're able to calculate this correctly in your calculator. Remember, we have to use our order of operation. So pause please here. So if hopefully you've calculated it correctly on your calculator and you've gotten 42.09. Now we need to decide how we're going to round this to get the percentile. Remember, when we're calculating percentile, we always round up. So that means this becomes the 43rd percentile. So the number 21 is in the 43rd percentile. That means that 43% of the numbers are less than or equal to 21. Now I'd like you to try example B on your own, please. So show all your work and bring it to class. Pause the video here, solve B. Now we'll try example C. Example C is one of the opposite examples. You're given the percentile, determine what number is in the 75th percentile. So the first thing we have to do is find the position. So to find the position of the 75th percentile, it's the percentile. This is the second formula we did in the notes earlier. So the percentile divided by 100 times the number of values in the distribution. In this example, we have 158 in the distribution. So 75 divided by 100, then times 158, that gives us 118.5. Now we need to determine what data value is in the 118.5 position, but we need to round this. Remember, in this example, when we're finding position, we always round down. So this means we're finding the 118th position. What number is in the 118th position? So we go back to our distribution, that's up here, and we have to determine where is the 118th position. To determine that, we need to go back up to our distribution, our list of numbers. So if we look here, we know that at this point, we have 61 values below it, plus 1, 2, 3. So it's at the 1, 2, 3 plus 61. This is the 65th number. Then we have 66, 67, 68, 69, 70. So that means that this here is the 70th number. So we're still not at the 118th. We have another 41 in between. So that brings us up here to 112. Okay, so we're getting close now. 112, 113, 114, 115, 116, 117, 118. This is the 118th number. So to finish the problem in C, we need to say that 57 is the value that is in the 118th position. So the number in the 75th percentile is the number in the 118th position, and that value is 57. So value in the 118th position is 57. That's the answer. So this would be like the test grade that is in the 75th percentile. Now I would like you to try example D on your own. Show all your work. So I'll be checking your work for B and D in class. Make sure you have shown all your work and you have a complete solution.